So here, let's start with the understanding that in pandas, the support for plotting is very simple. Everything starts with df.plot. All right, df.plot. So you can always say df.plot dot area dot bar dot bar. Well, that means just horizontal bar. All right, so not h bar but bar h. Dot box. So df dot plot dot box. Df dot plot dot density dot hexpin dot histogram hist dot kde kernel density dot line dot pi dot scatter. All right. So some of these useful and common ones will be bar chart, bar, and histogram, trend line, pie chart, and scatter plots. All right. Well, we'll see everything in a while. So the general standard to call the convention to call data frame to plot itself is df.plot a line. I want to see the line. So when you do that, it will plot a line. And of course, you can extract out the columns. Even series can be plotted. So for example, if we say start a new figure, right? Like here. So we start a new figure. Then we say df.d, take out the d column. So that's here. Remember, d column will also get a copy of the index, which will implicitly form the x-axis. So if we don't specify to override that, then the index will basically form the implicit x-axis to draw against the y values, right? The y values, if it's a trend line, of course the y values wouldn't make sense for the pie chart, but we know that the y values will be the extent of the pie, right? So because that is to show the extensiveness of the data. So we can say alternatively, if we don't want the dot line to be hard-coded, dot pi, dot scatter to be hard-coded, we can always say df.plot kind equals to line. So this alternative, I must stress is alternative, it's not a new different set of function, but an alternative makes df.plot hard-coded because it's fixed. But the line, here's the interesting part. You can actually, you see it's a string, right? Which means it can be a variable. We can always ask user, do you want to see line chart? Enter the chart nature. So if user enters line, then you simply say df.plot kind equals to nature. Nature is the input string that the user enters. So if the user enters line, you will see a line chart. If the user enters pi, you will see a pie chart. So that's quite cool because it can be decided at runtime rather than hard coded at program time. So these two very powerful conventions allow us, the programmer, very, very, versatile ways to deal with our whims and fancies or our users' very, very specific requirements. So if we look at this again, so we created the data frame, nothing to worry about. Then we create a new figure, extract the D column, plot a pie chart, right? Plot a pie chart. What are the X and Y values? X values will be these, all right? So of course the labels therefore are the X values. And then the Y values are the basically the extent. Yeah, so we can therefore find that label 0 has got very, very big extent. Label 1 comparable but smaller. Label 2, label 3 and 4 absent because they occupy 0 degrees, right? And so on. So that's implicit, but that makes it very, very convenient because look, it's understood to us, right? D is the data frame. We know it's going to be that. If D is the COVID occurrence in the 4th week number 4, then of course it's occurrence. So I want bigger angle for larger number of occurrences. So it's quite straightforward. Yeah. So, but then of course we have the ability to also override it using x equals to y equals to plot different values. Then we say, remember, this produces an object in the graphing space, right? This entire plotting area is an axis. Careful, I say axis, not x, right? Because there's no singular. Axis is both singular and plural. So the entire chart is an axis. And if we want to set a title, by default it's empty. We just simply say this chart, make yourself the title, pie chart of D, and we get this. Okay. We can further adjust various details depending on the nature of the chart. For example, the labels on the x-axis and y title, x title, and so on. So the as we understand in pandas, we can do a chain of dotting, right? Extract d, then dot sum, then dot sum again, axis equals to one, whatnot. We can do that. Yeah. So in the support for matplotlib pyplots plotting, we can actually also do that. So for example, we can say, let's plot the d column, df.d. All right. Dot plot dot py. I want to see a pie chart, and because it returns axis, it this whole prefix here, this part here, is to be thought of as an axis type. So it refers to the produced chart, which then can be commanded with set your own title as pie chart of D. So after a while, we'll find that having two lines to do this is really pretty upsetting. And having an extra AX just to hold it temporarily so we can refer to it and say set title, again, pretty cumbersome. You might find this very, very exciting now and totally not cumbersome. What's wrong with using AX? But if you need to draw a few tens of figures and charts or complicated settings and so on, you might just want to do it this way. Yeah. So this is more the pandas Python's way of doing things. So very quickly, I want to just give you a feel because visually we can identify the charts much quicker and much more able to appreciate what they are used for, what information they can tell or not tell. So I want to have this gallery here to show you the 9 different ways that pandas can support. This is a trend line, this is a bar chart, horizontal bar, right, bar hinge, um, density plot, which is a kind of like a continuous histogram plot. Just think of it that way, right? So density plot. Then we have the area, which is nice to show more visual impact, because if you show 4 lines like this, the trend lines, it's a bit skinny. It doesn't impact the eye because our eyes are not sure whether to capture the top part as significant or the bottom part as significant. So when we color it as layers, as area, it becomes much more, I won't use the word attractive because our purpose is not to attract and entertain the audience or the reader, but to visually, right, show the impact. All right. So next up is the histogram, and I'm using a bit of alpha transparency to allow multiple histogram bars to show through. And so when it changes color, it's actually more because um, we have the green here, but let me see. So yeah, it's because of the A and the C being overlapping on top of each other. So the with the alpha, with the help of transparency layers, semi-transparent layers, it gives us extra hint about the overlapping or non-overlapping areas, like the pure red squares over here. Then we have the box plots, very, very useful to quickly show us the distribution, right? And the median, the quartiles, the maximum, minimum, right? And any extreme cases or not, right? So, and then for comparison purposes, especially in applications like stocks, multiple stock comparisons, multiple country comparisons for foreign exchange, multiple country comparisons for COVID-19 cases, multiple precinct, maybe neighboring precinct comparisons to detect sort of community spread of virus and so on. So all these are very, very powerful, very standard also. So we just learned about box plot and scatter plot, very, very powerful to detect relationships, right, between two variables, two columns or two rows. And then we have the hex bin plot. That is something unique. So kind of shows the extent, uh, the sort of density of impact, in that sense. So it gives you a scale and also X and Y, pretty powerful as well. So here in the slide, summarized as 9 figures, we get to see the power, right? The ability that Pandas is able to support us in terms of generating these graphs. Now, do not use these graphs haphazardly. Do not abuse them. Use them for certain purposes. If your idea is to show fluctuations in time, right? Then you might want to use trend lines and not try to color it with area, because that's very confusing, especially when they cross, right? Um, you might also want to think about side-by-side comparisons. If that's the case, then vertical bar charts. Horizontal bar charts also quite frequently used. But then our inclination to detect differences with vertical bars are different from those with horizontal bars, especially when they're left aligned, right? And it's a bit not so natural. There are some people who are also left-handed, then they might prefer right aligned, but which looks very odd to all the rest of us. So, uh, however, for vertical bars, it's more universal. So we don't want to really um, segregate our audience quietly. Some are left-handed, some are right-handed. Then you show the bars aligned to the left, which may look very, which may divide opinion. And also we have histograms. So the actual histograms by bars, and also the continuous version of histogram, we call the kernel density. Also very useful. And box plots, definitely very useful. So we don't want to, like, for time series, show box plots. Wouldn't quite make sense, because these are distributions kind of ignorant of time, right? And then the essence of information is gone. When we are not sure about the relationship, we show scatter plot. We don't want to assert certain understanding that are not founded yet, right? So we do scatter plot and so on. So try to use each type of chart with clear idea of what you want to communicate, rather than, I think we need some colorful charts here. Let's draw some bar charts. So definitely ask yourself, what am I trying to communicate with this chart rather than that chart? What am I trying to avoid, in terms of biases or misunderstanding, by using this chart or this color or this scale, in terms of that, as compared to others? So definitely go through some serious questions and answers before you decide which chart to draw.